In this video we'll explain what engine pressure ratio is. So it is defined as the ratio of the turbine exit pressure to the engine intake pressure. There is a variant of it, and one of the variants is the integrated engine pressure ratio, which basically just compares the pressure at the nozzle and at the exit of the fan to the intake. So here we have our engine. If I include the engine station numbers, for this engine we have P1 at the input, we have PF here, which is the exhaust of the fan, and we have P9 here, which is the nozzle exit. Then the engine pressure ratio will be the ratio between P9 and P1. And then the integrated engine pressure ratio would be the ratio of P9 plus PF divided by P1. So that's basically what engine pressure ratio is. We can see its usefulness as a power indication. If I have my engine here, and here's my different stations, P1, P2, P3, P4, P5, and so on. And when the air comes in, there is some compression in the inlet duct, some compression in the fan, it gets compressed in the compressor, constant pressure burning, expands in the high pressure turbine, expands further in the low pressure turbine, through the tailpipe, sort of constant, and then as we go out through the nozzle, the velocity increases and the pressure decreases. So when we do all that, let's just say the input pressure, atmospheric pressure, is 100 kilopascals, and the pressure here, P9, is 120 kilopascals. So the engine pressure ratio is P9 to P1, so that's 120 K to 100 K, which is 1.2. So we have a pressure ratio of 1.2. If I was to push the throttle here forward, then we would expect the engine to produce a little bit more power. So the compressors will run that a little bit faster, the fan would run that a little bit faster. So if it was moving faster, we'd get more air into the engine. So the air coming in here there'd be more of it, and then the greater pressure increase. So what would happen would be the pressures would increase all along the engine. Okay, and then when it goes out through the turbines, they drop off. But let's just suppose that having pushed the throttles forward, my pressure here is 180 kilopascals. That's shown here, 180 kilopascals. Well then, engine pressure ratio is P9 is to P1, which is 180 K to P1 here, which was 100 K. And that gives me an engine pressure ratio of 1.8. So you can see, by looking at the pressure ratio, you can see how much thrust or how much power the engine is producing. When it's displayed on the cockpit, so it can be a standard analog gauge, where you just read off what your engine pressure ratio is, or in ECAM or ECAS system, it would be displayed something like that. Okay, so I hope that explains what engine pressure ratio is.